That was not going to be terribly exciting because we can't actually bring guns onto campus. But we built a little device that actually detects when you fire a shot through a rifle and keeps account of that. Basically counts down however many bullets you have left in your magazine. And so we have a minor demonstration here with a little piece of metal, a standoff that simulates a bullet. If you can see right now, let's see if I can hold this up for you.
After the reset or something like that. Anyway, so the way we accomplish this is we built a metal detector. The LPC Expresso generates a 1 megahertz signal that goes into the 2 coils, and they have a certain coupling, and when the metal bullet passes through there, you throw off the mutual inductance, and we have a bunch of analog circuitry that then detects that and sends the signal to the board to count down. So this is going to be the simulated bullet. You drop it through, can't see an outlet, it counts down. And then the idea of when you change out your magazine, you have a little magnet on the magazine with this magnetic read switch. You pull it off, put the new magazine in, and it resets the count.
The idea is to turn this into something that's a lot more integrated in the future. So more sensing circuitry, so you can have a lot of diagnostics of your weapon available at any time. And the other idea, of course, is to make it as simple as possible because you don't want a lot of information overload cluttering you out. So you just want the minimum information available that you need. So here we just have a pair of 7-segment displays that have your remaining shot count that would be, easily and quickly acquirable.
And we did test this out with the rifle, but unfortunately our attachment method to the front of the muzzle wasn't strong enough. We have a little video here to show you what happened.
But we did verify that the bullet passed through our pair of coils. So if we have it mounted more securely to the muzzle, it will in fact give us an accurate reading. And in fact, a lot of the problems, or the minor problems we have here with doing double counts are just due to the low speed of our simulated bullet. So when it's traveling at 900 meters per second, that shouldn't be an issue.
So actually, 2 comments here. So first one is use 1 megahertz, right?
Yes.
So you think 1 megahertz is definitely fast enough to capture the signal?
Very definitely.
So
the bandwidth we need is about 100 kilohertz or so.
Okay. The second comment is this, right? So if you don't use this sensor, instead you use some motion sensor like accelerometer, you may be able to track all these vibrations of the weapon. From that, you can diagnose the condition of the weapon. I think that would be really interesting.
Yeah, and something, a benefit with this is if we do integrate it with an accelerometer, you can sense squibs, which is a failure for the round to exit.
Exactly, yeah, and also because in the harsh environment, right, you keep on shooting, you get really hot. Then all this vibration, everything will become different.
Exactly.
You'll see different signatures that can really help you to basically protect your weapon. Right. Yeah.
Right. And so the idea maybe would be that you have immediate information available right there, and then perhaps communication with a third device that can keep track of more complex diagnostics that you don't need in the moment.
Yeah, I think that'd be really useful because then you keep on tracking your weapon because the weapon being used like through all the missions, right? Training and everything. So you essentially get lots of data over the time about the healthiness of each of the weapon. So when you go for mission, you can pick the best with the weapon with the best condition, possible condition to do that.
Precisely.
Right? Yeah, collecting lots of data, continuously monitoring all those weapons. I think that's a very important job. Yeah.
Cool. All right. Great.